Hello there, welcome to another problem session. So today we are doing 2023 IIT JEE Advanced Paper 1, and we are on to the last section, and this is the third problem, last section, question number 16. So here is the question. So this question is about a series LRC circuit. And the source is given. This is the angular frequency of the source, so this is an AC source, and it says in AC source the LRC circuit is a resonant circuit, so at some frequency you'll find resonance, and the resonance frequency is this. Current amplitude is I0 at the resonant frequency. You have circuit is this, and the amplitude of the current is I0, which is not given, which actually have to be found. One of the possibilities you have to find. So L is given, and omega R is given, but at another angular frequency the current actually drops to 0.05 of I0. So we're supposed to there are things you can calculate about the circuit that's given in list 1 and check against which of the answers is correct. And these are the possibilities. We discussed earlier that over here you have to look at what is the most distinguishing. If you could calculate all of this, then you go for the most distinguishing one. And here I see Q. If I can calculate Q exactly, then finding this quality factor of the circuit will actually solve this problem. Alright, I don't have to solve other problems. I don't have to calculate other things to save time, right? However, if I didn't know, if I could only calculate I couldn't calculate this. I didn't know what the quality factor formula is exactly, but I could calculate I0 or calculate peak power, whatever bandwidth. If I calculate those things, I'll go and calculate those things. That will narrow it down. All right. So there are two strategies. One is like, okay, which thing that if you can calculate everything, then pick the one that distinguishes it. Or among the things you can calculate, pick the one that distinguishes the most. And so in LRC circuit, let's see what things we should know for LRC circuit. Okay, in LRC circuit, if you remember, this is some AC source, and V0 sine omega t. Usually I use cosine, but doesn't matter. Let's see, L R C. So this is the circuit, okay? And when change this, you're going to find a resonance. So the current is I of t at some instance. So I of t will have some kind of I0 sine omega t plus phi in a steady current, right? If the circuit has been closed for a long time, so that's the steady current. And there is a formula for phi, and there is a formula for I0. I0 will be related with V0. I0 will be V0 over Z, and the Z is square root of R square plus omega L minus omega C square. At resonance, this will have to go to 0. Omega square will be 1 over LC, or So omega resonance is 1/square root of LC, and Z just becomes R. At other frequencies, this depends on omega. All right, so this is if you look at the power, etc., power will be I0 V0, peak power. Okay. All right, so we can so that's one thing. Another thing that you would know is quality factor. Quality factor probably you know from its analogy to this circuit has analogy to harmonic oscillator, which has a driving force, so like mx double dot plus bx dot is a dot equals ddt plus kx equals to some force f0 sine omega t. So it's same kind of, if you work this out, the formula, it will be L, if at some time you have a qt here, so, q dot plus r q dot plus 1 over c q equal to v0 sine omega t. So this circuit, so they have exactly same kind of relationship. So from here, you know, just looking at the damping part, suppose set this to 0 and looking for the damping part. From there you can divide by m x double dot plus b over m x dot plus k over m x equals f0 over m sine omega t. If you call this gamma and call this omega naught square, then Q factor is omega naught over gamma. So over here Q factor, doing exactly like that, same way. So gamma will be R over L and omega naught square will be 1 over LC. So Q factor will be omega naught over gamma is L over R 1 over squared LC. You can see that 1 over R is square root of L over C. Okay, so for Q factor I need to find what the R is, right? So if we were going for the this Q factor, that's the most distinguishing thing I need to find, and I will check that answer after I find this, whether I0 is the same, is consistent. So I definitely need to find what R is and what C is. In this question, L is given. So let me so that's my strategy. Find R and C. Well, I can find C. Omega R equals 1 squared LC. So omega R square equals to 1 over LC, and omega R is given. So that means C equals to 1 over omega R square L, just from this. So I can just find C very easily. So I'm not going to work it out, I just know I can find it. So just so I found this. So need to find R. How do I find R? What's given is current amplitude. This this current at two different frequencies are given. So what's given is I0 at omega r is given. Yeah, we are calling it I0, which is V0 over R. So one is given, and I0 at omega is 0.05 I0 V0 over R square plus this whole thing. Okay, clearly I can take a ratio of this and V0 disappears. You can say 1 over 2. So 1 over 2 is 1 over 0.05, and this is R, square root of, I don't have to write this whole thing is over there. R goes this way or that way, so we get R square equals 0.05 square R square plus omega L minus 1 over omega C square. So I can bring over here, and 0.05 square is really 0.05 square is 5 over 100 square is 25 over, and this is much less than 1. So when I bring this and subtract it, so approximately this equation is R square omega L minus 1 over omega C square. So that just gives me R equals to omega L minus 1 over omega C square. All right, so now I just use the C in here and things like that, and let me work out the calculations to save time. Just while I was working it out, I said this is square, this is not square, so this has to be worked out. If let's see, omega is given as omega is 8 times 10 to the power 4, and L is 50 times 10 to the power minus 3 minus 1 over actually I can do it better job, than that. Can we do faster? So R equals to, pull the omega out, and then so L minus 1 over omega square C. So if you look at this, C equals to 1 over omega R square L, then 1 over C equals to omega R square L. So this is omega R square L. Pull L out, omega L is 1 minus omega R square over omega square. Omega R is 0.8 omega R is omega. That means omega R over omega is 1 over 0.8 is 10 over 8 is 5 over 4. And so this is 1 minus 25 over 16, that's 9 over minus 9 over 16, and absolute value 9 over 16. So 0.8 times 10 to the power 5, and L is 50 times 10 to the power minus 3, times 9/16, and so this 8, and this becomes 4, and this 8 cancels out to 2, and 9 times 4 is 45, and 10. So I calculate it, let's call it 45/2. 1 0 makes it 5, 10 to the power 2. So 45 C. I see some mistake here. I didn't carry it over here. 0.05 square, 0.05, 0.05, and so this is 0.05, 0.05. So this is also times 0.05 times 0.05. So 22.5 times 10 to the 2 times 5/100. Maybe I can just write down 1/10 times half. So 211.25. So the R turns out to be, it's an important quantity to have done right. I was kind of too hasty in my calculation. So it becomes 112.5 ohm. So the R is that, and now we can use R to find out the Q, okay, and also to find I0. So we have all these tools now. Let me go and get another piece of paper. Okay, so just to recap, we got this. I'm on a Q factor. Q factor will be this, and so 50 times 10 to the minus 3. This is millihenry, and R is 112.5, and 1/square root of LC is 10 to the power 5, and all in the SI units. Now I need to kind of work this out. So 5 and 6. So if you do 50, let me see where it's going to land, right? Let's see, make it 500. 12.5 times 10, so one more 0, so 10 just times 10. So it's going to be roughly 4.5 or something like that. This would be roughly 4.5 or something. So this is roughly 45. And all I have to do is check what's in the answer. So in the answer, choices that are given is 44.4, 80. So they're all different enough, sufficiently different that I don't need to be very exact. So the Q is supposed to be 1, and Q is supposed to be, that's just a B. So the answer is B. So from this, I already know the answer is B. And I can move on. If I'm short on time, I don't have to go and check more. But if I'm a little bit hesitant to move on, I can check on I0. So I0, which is P is supposed to be 3. So 400, and it's also a lot different, right? So let's look at I0. I0 will be V0 over R. This is given at omega equals to omega R. That's the case. And so V0 is given as 45 volt, and R, which is found out, 112.5 ohm, and its answer is in millihenry, so times 1000, that gives me milliamp. I'm sorry, I0 is supposed to be milliamp, so I was going to get amp, I'm going to make it milliamp. So let's see, 112.5, 45, maybe put another, take 1 0 out of it. So if I have 4 times this is 450. Okay, so this is 4 times 100 milliamp, and this is 400 milliamp. And I go look at it. Q was 1, so P is 3. P is 3, so P is 3. So that also gives me P is 3, so that also gives me answer B. Don't need to do more than that, okay? If you want to go ahead and calculate the other things just for the practice, is a good idea if you're practicing it, but for the sake of exam, you're just ready to move on. Okay, so the next problem and the last problem is an interesting problem, and it's coming from electricity and magnetism, and we're going to do this, also a standard problem. I'm going to do it in the next video.